The research problem for this title were due to the population of the world increased. The demands for food and vegetables increased as well. However, the fast and efficiency agriculture for producing the crops are playing an important role throughout the world. But not every country are using an efficiency system for their crop production. Some of the countries are still using manpower to maintain their yield in the greenhouse. The problem are human workers not really care about the climatic factor like temperature and humidity that will affect the quality and quantity of the crops. Therefore, an intelligent control system are required to be implemented for monitor the temperature and the factors. Once the system detected any problem, user will get notified by the device and the system will immediately do the corrective actions. Since Malaysia, which is a country that the climate categorized as only humid and hot conditions throughout the year, this proposed system which enable the crop to grow in the suitable and perfect temperature conditions that will benefit the productivity of the crop. Here we got the aim and objective for this title. The aim of this project is to design and analyze the greenhouse temperature control system. The first objective, which requires students to enhance the conventional control system that done by the researcher and enhance their works, also overcome their drawbacks of the system. The second objective, which requires students to develop an efficiency and targeted monitor the temperature mechanism and computerize the temperature data value that received from the greenhouse. Last objective, which requires students to evaluate the most accurate algorithm and integrate the system with IoT. There are certain assumptions while conducting this control system. Wi-Fi connection has to coverage the entire greenhouse. The temperature and humidity are measuring in Celsius and percentage. Carbon dioxide level are in part per million ppm unit, and the type of harmful gases will be detected are propane, butane, and LPG. Last but not least, the proposed control system will monitor the greenhouse 24/7. Here we have the rough idea for this control system and a 3D sketch rough design by using SolidWorks drawing to represent the prototype. Also, we label all the components in detail such as the crop, heating and cooling water pump, humidifier, intake and exhaust fan, LCD display, and the ventilation system as well.
So first of all, I will introduce all the components. Here we got our carbon dioxide, smoke and gas sensor, buzzer alarm, the ventilation, the window, just an example here, will be different in the greenhouse later on. And we got our heating system, exhaust fan, LCD display, intake fan, our relay, also our cooling system, and our humidifier and our DHT22. So here we got our push button and our Node MCU and the Arduino microcontroller. So this is the LCD display. Here we show all the temperature, humidity, carbon dioxide and the gas status, detected, not detected. Also we have a mode here. M stand for manually and A stand for automatically. And here we got 6 relay, but we only using 5 of it. So to control this 6 relay, we can control by manually by push button, and also we have a IR receiver here, so we can control by our controller remote. Also we can control by our IoT software Blink application to control the on off of the relay. So now I will demonstrate how do I control this. So when I push this, the first one will off. So we can use this. So these are the 4 relay, and this 2 is the ventilation on off. So when I press this one, we can on off the window, and this one stands for C mode, which is change mode. So we can change the mode for the automatically and manually, and this is the emergency stop button. So whenever we press this, it will immediately turn off all the relay. So now I will demonstrate the auto mode for this system. Before that, user have to enter the maximum temperature and the minimum temperature value. So our objective is to let the greenhouse operate in between these two values of temperature. If the sensor temperature are greater than maximum temperature 34 degree, then the exhaust cooling system and the vent will be open to reduce the temperature. If the read temperature are lesser than the minimum temperature, our intake fan, heating system and the vent will be closed in order to increase the temperature. So this is the cooling system and this is the heating system. So now I'll demonstrate for the auto mode, and the temperature now is 29.7, which is in the second condition. The read temperature are lesser than the minimum temperature, so the intake fan, the heating system will be turned on and the vent will be closed in order to increase the temperature. Now I will switch the mode into auto mode. So the third and the fourth relay will be turned on. And now I will turn on the power supply. The fan and the hot heating system will be turned on. So this is the UI interface for this greenhouse temperature control system in Blink. Here we got a gas leakage detection in the first one. So this will indicate the status. So whenever gas detected, the red bar will increase until here. And here is the humidity, carbon dioxide, temperature value here. And this mode will show what's the mode, the current mode now. We got manual and automatic mode. And we got the pin to control the relay here. Also a chart here to show the temperature monitoring chart. So now we can use this pin to control the relay. I will demonstrate now. Whenever I press this one, and the exhaust fan will be turned on. So when I press this one, the water pump, and when I press this one, the fan turn on, water pump, and last but not least the humidity high.